Okay, this is problem 13. We have the integral from 0 to 2 of the integral from 0 to 4 of y cubed e to the 2x dy dx. Okay, so we start with the inside again. And if I start with the inside first, we're taking the integral with respect to dy. That means, or with respect to y, I'm sorry. That means that e to the 2x is a constant. So I'm just going to write it down. Okay, and let's talk about that y cubed. So now I'm going to add 1 to the exponent. It's y to the 4th. And then divide by that new exponent, 4. Okay, and I'm going to need to evaluate that from 0 to 4. This, of course, is all the while that other integral is on the outside. Okay, I'm going to rewrite that 0 to 2. And I'm going to put that dx out there. And now I'm ready to evaluate it. Now remember, you took the integral with respect to y, so everywhere you see y, we're going to plug in a 4 to start with. So I have e to the 2x, 4 to the 4th over 4. Okay, now let's plug in the 0, minus e to the 2x, 0 to the 4th, all over 4. All right, so that gives me the integral from 0 to 2. Well, this becomes e to the 2x. Well, there's 4 4's up here. There's 1 down here. So that's just going to be 4 cubed. This 0 makes that chunk right there 0 out. Okay, so now I have the integral from 0 to 2 of 4 cubed. So that's 16 times 4 is 64. E to the 2x dx. Now, we know that this originally, we know that the derivative of e to the x, if I have y equals e to the x, y prime equals e to the x dx, right? Okay, so that means that this e to the 2x, so I can bring down that 64, was e to the 2x, okay? And then what was that chunk? If it was still e to the 2x, then I had to take the derivative of the 2x to start with, okay? And so that would have been what? That would have been a 2. So I'm going to divide by 2, because let's think about it. And here's the easiest way for me to think about that. I know that was a little confusing, because I know that if I have e to the 2x, and I take the derivative of that, that gives me e to the 2x. And then what's the derivative of 2x? That's times 2. Okay, so we want to get rid of that. So we're dividing by that 2. Okay, and that's all from 0 to 2. Now, let's think about it. I'm going to go ahead. This is really saying, what is that, 32? E to the 2x. And the way we can check that is, okay, if I have y equals 32 e to the 2x, and I take the derivative of that, that would be 32 e to the 2x, and then derivative of 2x is just 2. So that means y prime would have been 64 e to the 2x, and that's what that was right there. You have to remember, an integral is just undoing the derivative. It's like somebody took the derivative of this unknown function and said, okay, here's the derivative, and somebody asked you, okay, well, what was it before you took the derivative? So that's called taking the integral, or it's the antiderivative. Some people will call it an antiderivative. Okay, so I'm ready to plug in 0 to 2. We took this with respect to x. So everywhere I see an x, I'm going to put in a 2, and then I'm going to put in a 0. So I have 32 e to the 2 times 2 minus 32 e to the 2 times 0, and that's 32 e to the 4th. E to the 2 times 0 is e to the 0, which is 1, and that's minus 32. The book might have you write that as 32 times e to the 4th minus 1. We'll see. I would take either one of those.